Welcome back to our channel. In the last video, we introduced differentiation as the slope of a curve at a point. Today, we'll go deeper and see how to actually calculate this using the first principle of differentiation. We'll walk through examples step by step, so stay with me. The formula on the screen, which is given by f prime of x equal to the limit as h tends to 0 of f of x plus h minus f of x, all that divided by h, is known as the first principle of differentiation. It comes from taking the slope of a secant line and then shrinking the distance to 0, so we get the exact tangents. You don't have to worry if limits feel strange, just follow the steps carefully and you'll see how it all works. So as we said, we're going to work this out through examples. So we're going to start with our first example. Let's say example 1. Find the derivative f of x equal to x squared using the first principle. Okay, in order to solve derivative of f of x or to differentiate f of x using the first principle, the first thing we do is recall our formula for the first principle. From our formula, which is this, the next step is to identify the different terms in the formula. So in this formula, we have two main terms which we have to calculate. Our first term is f of x plus h. Our second term is f of x. And so we're going to first of all calculate these two terms. So let's start with our first term, f of x plus h. How do we calculate f of x plus h? F of x plus h can be calculated by replacing every x in the f of x by x plus h. That is, f of x plus h is just x plus h squared. Now simplifying this, we get x plus h times x plus h, which gives us x squared plus xh plus xh plus h squared, which gives us x squared plus 2xh plus h squared. So we're going to now calculate the numerator. Our numerator is f of x plus h minus f of x. So f of x plus h minus f of x is given by f of x plus h, which is what we got above, x squared plus 2xh plus h squared minus our f of x, which is this. We have x squared. Simplifying this, we have x squared plus 2xh plus h squared minus x squared. We have our like terms here, x squared minus x squared, and this cancels each other out. So we have 2xh plus h squared. Having this, we notice that h is common in both terms. That is 2xh plus h squared, which is the same thing as h times h. We have an h common here and an h common here, so we can factorize out h, which gives us 2x plus h. Yes, so our numerator is complete. Now back to our denominator, which is x. We are now going to calculate all of this term, the whole of this term. So in order to do that, we are going to just, since the term is f of x plus h minus f of x, all that divided by h, we have f of x plus h minus f of x divided by h is going to be our f of x plus h minus f of x is the term which we calculated above here, 2h into 2x plus h all over h. So we notice that h is common in the numerator and the denominator, so they cancel out, which gives us 2x plus h. So what do we have? We can then, we have the term f of x plus h minus f of x, all that on h, equal to 2x plus h. So the next step to do is to work out the limit. That is, calculate the limit as h tends to 0 of f of x plus h minus f of x all over h, which is the same thing as the limit as h tends to 0 of 2x plus h. Yes. So what do we mean by limits? Calculating the limit of a function as h tends to 0 boils down to replacing every h in that function with 0. So calculating the limit of this function as h tends to 0 is same thing as replacing every h in this function with 0. So this gives us 2x plus 0, which gives us 2x. So what does that tell us? This implies that the limit as h tends to 0 of f of x plus h minus f of x all over h is equal to 2x. But when we recall from our function above, we notice that all of this formula is the same thing as the derivative of f of x, which is known as f prime of x. So we can then conclude that, therefore, the derivative of f of x, which is f prime of x, is equal to 2x. And from this, we can then conclude that our example is complete. We have solved the derivative of f of x, which is x squared, and we obtained the answer as 2x. And the answer is perfect. The method is perfect. So we are going to move on to practice questions. Our first practice question is practice question 1. Question 1. Differentiate f of x equal to x cubed using first principle. So I'm going to leave people some time to pause the video and solve it on your own in order to actually verify if you have understood the method of calculating the derivative of a function using the first principle. So you can leave your answers in the comment below so that I can check later and we can all comment on your methods and everything. So I'll assume that if you are watching now, you should have attempted the question and come out with an answer. So we're going to tackle this question then. Recalling back our formula for the first principle, we know that f prime of x is the same thing as the limit as h tends to 0 of f of x plus h minus f of x, all that divided by h. This is our formula of the first principle. So same thing as our first video, we are going to tackle term by term. So let's start with our first term, f of x plus h. This term is the same thing as x plus h, all that cube, which is the same thing as x plus h squared times x plus h. Now, if we recall from our first example, x plus h all that square is the same thing as x squared plus 2xh plus h squared. So we are just going to replace it in our second practice question, which is the same thing as x squared plus 2xh plus h squared. Now all these times x plus h. Now multiplying term by term, we have x squared times x cubed, x squared times h plus x squared h, 2xh times x plus 2x squared h, 2xh 2xh times h plus 2xh squared, h squared times x plus h squared x, h squared times h plus h cubed. So Here we are going to assemble, sorry, here is cube. Yes, cube, since it's x squared times x is x cubed, not x squared. So we are going to assemble like terms. We have first of all x cubed. Now our term x squared h, there's x squared h here and there's also x squared h. So those two are like terms. This gives us plus 3x squared h. We have 2xh squared and h squared x, which is the same thing as xh squared. So we have 2 and 1 here, which gives us 3x squared h plus our last term h cubed. So moving on to our next term, which is f of x, we have f of x is the same thing as x cubed. So we are then going to we will now calculate the numerator, which is f of x plus h minus f of x. So f of x plus h minus f of x is the same thing as our f of x plus h, x squared x cubed plus 3x squared h plus 3x, sorry, here is xh squared plus 3xh squared plus h cubed minus x cubed. Simplifying this, we notice that x cubed and x cubed are common and there is a subtraction here, so x cubed minus x cubed, which cancels out. This leaves us with 3x squared h plus 3h xh squared plus h cubed. So the first thing we are going to do here is factorize out h. Since h is common throughout, we are going to have h into 3x squared plus 3x h plus h squared. So then we are going to calculate the fraction f of x plus h minus f of x divided by h. This gives us h into 3x squared plus 3xh plus h squared divided by h. We notice that h is common in the numerator and the denominator, so they both cancel out, which leaves us with 3x squared plus 3xh plus h squared. Calculating the limit of this, limit as h tends to 0 of our term f of x plus h minus f of x divided by h is the same thing as the limit as h tends to 0 of 3x squared plus 3xh plus h squared. As we both said in the previous example, the limit of this can be calculated by replacing every h we have in this function by 0. This gives us 3x squared plus 3x into 0 plus 0 squared, which gives us 3x squared. As this term cancels out, this term cancels out. Since it is anything times 0 is 0, 0 squared is still 0. So we are left with 3x squared. What can we then conclude from this? From our formula of first principle, which told us that f prime of x, which is the derivative of f of x, is the limit as h tends to 0 of this term. We have calculated this limit of this term, so we can then conclude that any answer we had in this is the same thing as f prime of x. So this gives us our conclusion: f prime of x equal to 3x squared. We can then come out with our general conclusion. Therefore, the derivative of f of x, which is equal to x cubed, this can be represented as f prime of x is equal to 3x squared. And we have our answer. So in order to verify your comprehension, we are going to move on to a third question. If you notice well, there is a pattern. The power comes down in front and the exponent reduces by 1. We'll soon formalize this as the power whole, but we are not yet there. Yes, if you notice the pattern here, we have x squared. This cube came down and this power reduced by 1. Same pattern as in the first question. Here was x squared. This power came down and the power reduced by 1. Yes, so there is a pattern, but we are not yet there. So forget about it for now. Let's move on to our third practice question. Practice question 2. Yes, so here, let me copy down the question first. Differentiate f of x equal to 1 on x using the first principle. Yes, this question seems much more complicated with respect to the first question. So if you want to attempt this question, you can simply press the video here and attempt it. Then you leave your answers in the comments below. So now we're going to continue, assuming that everybody that is here right now should have attempted the question. So the first thing, we're going to follow the same steps as the previous question. The first thing to do is to recall our formula for the first principle, which stated that f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x, all that divided by h. So the first thing we're going to do is calculate term by term as the other questions. F of x plus h is the same thing as what? 1 on x plus h. F of x is the same thing as 1 on x. So f of x plus h minus f of x is the same thing as 1 on x plus h minus 1 on x. So we can simply, I'm going to use the same method we used when we were still in primary school and beginning secondary school. Yes, so this gives us this and this. Yes, we have here x minus x plus h, which then gives us h on x into x plus h. Just so you know, there's a simpler method to do all of this rather than doing what we did here. The first thing is you can identify their denominators. You have x plus h here and x. What we want to do is have a common denominator for both. So what can we add to this in order to make both of them common? The best way is to do this. 1 into x plus h. We add an x here and add an x in the numerator. Why do we add in the numerator? To avoid a complete change of the equation. Yes, so these x's can still cancel out. Yes, minus, here we are going to add an x plus h in the numerator and also add it in the denominator. After doing this, we notice that both their denominators are common, so we can simply subtract their numerators. So subtracting their numerators, we have x minus x plus h, all that on x plus h times x, which gives us negative h into x plus h. If you notice in the previous method, forgot to add this negative sign, which was an error. Yes, so let's continue. Okay, yes, so this is it. We are going to move on to our next term, which is f of x plus h minus f of x, all that divided by h, which is the same thing as h into x plus h, all that divided by h, x plus h times 1 on h. H cancels out on both sides. We have negative 1 on x into x plus h. Okay, let's go. So calculating the limit as h tends to 0 of this term, is the same thing as the limit as h tends to 0 of negative 1 on x plus h which is the same thing as negative 1 into x plus 0, which gives us negative 1 on x squared. So what can we then conclude? Therefore, f prime of x, which is the same thing as the limit as h tends to 0 of f of x plus h minus f of x, all that on h, is equal to negative 1 on x squared. Yes, so that is our conclusion. The derivative of f of x equal to 1 on x, which is the same thing as f prime of x, is equal to negative 1 on x squared. And our solution is done. So, for a quick remark, today we learned how to use the first principle of differentiation to find the derivative step by step. We saw it work for polynomials and even fractions. Yes, so in the next video we are going to introduce the power rule, which is a shortcut to make this process much more faster. So I want to thank you for this video. Yes, you move on to the next video. If you have any remarks, any questions, you add them in the comment section and I'm going to get back to you. Thank you.